Our planet moves in a few different ways. As it rotates on its own axis, different parts are presented to the sun at different times, which is what gives us the day and night cycle. In addition to this, Earth is slightly tilted as it rotates, which creates the seasons, and is the reason it's summer in the southern hemisphere while it's winter in the north, and vice versa. Earth spins around this axis at 1,000 miles an hour, which sounds fast until you hear how quickly it orbits the sun. Each year, Earth has to travel at 67,000 miles an hour to complete its circuit of the sun, while the sun pulls the entire solar system through the galaxy even quicker, at a huge 490,000 miles per hour. Although Earth itself is only rotating relatively slowly, the escape velocity for spacecraft to leave Earth's orbit is 25,000 miles per hour. That's how fast the Apollo astronauts were going on their way to the moon, with the Command and Service Module docking with the Lunar Module at a speed of 3,600 miles an hour, over 3 times as fast as Earth spins. If all that stopped with absolutely no warning, rather than a gradual decline in rotation speed, we'd have a big problem. But perhaps not the problem you imagine. We wouldn't all fly off the planet's surface into outer space, for instance. The planet stopping isn't like when inertia keeps a body of water in a bucket as you spin it around, because gravity isn't created by the speed of the Earth spinning. Gravity is determined almost entirely by the mass of an object, and Earth has the same mass no matter what speed it's moving at. In fact, the faster Earth moves, the less gravity affects it. Objects actually weigh slightly less at the equator than at the poles, because that's where the rotation is quickest. This means that you're going to have a stronger gravitational force to contend with, relatively speaking, if Earth stops spinning. But at least we won't all immediately float away, nor will Earth spontaneously lose its atmosphere. However, the same gravity that keeps us tethered to our home would also cause serious problems if Earth stopped moving. One thing that would start to happen right away would be that with nothing to counteract it, gravity would begin to mold Earth into a perfect sphere. Currently, Earth is technically an oblate spheroid, meaning its surface is irregular. It has different tectonic plates at different depths, mountain ranges, and most importantly, a slight bulge at the equator, making it wider in the middle. If Earth stopped moving, the planet's surface would begin to change until gravity forced it to be uniformly flat, something that would have devastating impacts for people around the world. But the most immediate damage would be in the equatorial range. Just because we'd still have gravity doesn't mean that the sheer force of Earth stopping in place wouldn't throw people around. Those on the equator would be catapulted eastward, as would buildings, objects, and most dangerously of all, water. Tsunamis of unimaginable scale would be produced as an immediate result of the sudden stop. As Earth's topography shifted, the oceans would be pushed away from the equator and towards the poles. This means that the equator would become a long ring of land wrapping all the way around the planet, while land masses close to the poles would be submerged in all that displaced water, creating 2 completely separate oceans. We'd probably have no way to predict this event, and it would happen so quickly that evacuating would be extremely difficult. Suffice it to say, the immediate outcome of a still Earth would be widespread tragedy and a complete change of Earth's geography. It would be terrible for humanity and every other creature in the long term, too. Earth's atmospheric currents would initially continue to flow, but would soon get slower and slower. Eventually, we'd have no wind and nothing to carry rain. It's impossible to predict how this would change the climate, but it certainly would. Potentially, those boiling hot deserts at the equator could cool significantly, which would be both good and bad. It would be bad because it would likely destroy the habitats of all the creatures that make the desert their home, but good because it would provide more habitable living space to the remaining humans who have no choice but to live along the equator now. A still Earth would also have the surprise benefit of preventing hurricanes, but again, this is a double-edged sword. Hurricanes might be massive disasters for humans, but they're important to the ecosystem, bringing rain and moisture with them. But possibly the worst part of this long domino effect would be the eventual demise of the magnetosphere, and it would go out not with a bang, but with a whimper. A major factor in maintaining Earth's magnetosphere, which is what stops our atmosphere from being washed away by corrosive solar winds, are the centrifugal rotations inside Earth's mantle and core. Mars famously has an extremely weak magnetosphere, and its mantle has likely solidified, so it isn't moving anymore to generate this centrifuge and keep the magnetosphere fueled. Because of that, Mars has a thin atmosphere made up almost entirely of CO2, making it extremely inhospitable. If Earth's magnetosphere begins to dissipate, we can expect our planet to become another barren Mars in the solar system, with aliens speculating on whether it was once capable of supporting life. Of course, with everything else going on, humans might not last long enough to really feel the impact of the loss of the magnetosphere. If Earth stopped spinning on its axis, you could forget about the sun rising and setting as usual. Our 24-hour day and night cycle would be a thing of the past. As the Earth continued to journey around the sun, the side facing the sun would eventually alternate. But it would take a year for us to get a full day and night. 6 months is a long time to live in darkness, although some 4 million people in the Arctic Circle do already live with prolonged nights today. Eventually, though, the Earth might become tidally locked to the sun, the way the moon is to Earth, meaning that one side of the planet would always face the sun while the other remained dark. In either case, the survivors of Earth's sudden stop would fare better at the edges of the dark side than in the light. Though the thought of constant darkness is more frightening, the side of the planet facing the sun would be baked to oblivion by solar radiation. You'd struggle to live there at all unless you went underground. The dark side would be colder, but it wouldn't be inhospitable. The sustained cold of facing away from the sun would be unpleasant, but it's far easier to warm yourself up than to cool yourself down. And at least we could still use UV lights to cultivate plants and grow food by building arrays on the light side. In this scenario, however, though Earth isn't rotating on its axis, it is still rotating around the sun. What if Earth not only stopped rotating on its axis, but also stopped dead in its orbit? Though this is almost definitely impossible. Earth moves through space just like absolutely everything does. Nothing in the universe is ever still. We'd have all those same problems to worry about, plus one more. Without motion, Earth would not be able to maintain its balanced orbit with the sun. The Earth's rotation around the sun is the Earth always on the brink of falling into it, with gravity maintaining a distance. If it stopped moving, it would go tumbling faster and faster into the sun, which would slowly burn us all up, regardless of what side of the planet we were on. If Earth suddenly stopped, some people would perish immediately from the force of being thrown to the east or from monster tsunamis. Others would hold out for a while, following mass movement to the darker parts of the equator. And that's what would happen if Earth suddenly stopped moving.